we're going to go over topic 2.1, motion, at least the first part of it. So this is called kinematics, or the study of motion. So when it comes to describing motion, there are 5 main things we need to keep track of. We're going to keep track of the position, which is represented by the letter S, but S can also mean the distance you've traveled. Initial velocity, which is U. Final velocity, which is V. Acceleration, which is A. And time elapsed, which is T. Don't write that down yet. We are going to talk about them individually, and so you have more time to kind of write everything you need to know about them. Okay, before we get into this, you need to know, obviously, that when we talk about motions in class, we're going to be kind of very specific, and we're going to be talking about things on Earth. There are lots of motions that extend outside of Earth, the fact that Earth is moving and that it's orbiting the sun, but we need to kind of simplify down. So we're going to just assume that we're looking at the motions compared to Earth. That will be our frame of reference, and it's an assumption we make in physics. You'll get used to it. We make a lot of assumptions. Okay, now the first definition, position, S. Usually a position is a location and it's somewhere in a 3-dimensional space, but for physics we're going to simplify to 2 dimensions. The classical horizontal motions, which you would think of as X in math class, and the Y vertical motions. All of the positions will be represented with the letter S, and that's just to create a consistency in the formula. Now, when you're setting up a position, you have to create a scale and some sort of a reference for where 0 is. Your scale can go horizontal, as you would expect it to, or vertical, as you would expect it, but it also can go tilted if it makes more sense. For example, if you're talking about things on a hill, you may want to have a slanted axis that'll help you with simplifying the math. And so these are 3 examples. And so they use general variable S to describe the position, and the plus or minus, you get to decide, is it up or is it down, is it left or is it right? And it depends on what specific problem you're doing, which is most helpful. So after that, when we talk about distance in physics, we have to be more specific than we are in English. And so there are 2 words. Displacement is the distance in a given direction from that fixed reference point that we talked about in our axis. This is what we'll use typically, and it's represented by a delta S or a triangle S. It's a Greek letter. And it's always found by taking your final location. So say you're talking about X positions, X final or XF, and subtracting where you started. So minus XI or X initial. The other kind of word for distance is going to be actually distance. And it's the distance you travel during a motion, represented by the letter S. I like to think of the difference between these in terms of someone going for a run. So let's do an example. If this picture is going to be someone going on a run, the blue track is going to represent their displacement as they ran. But at various times, A, B, C, and D, and E, you could measure how far away they are from the starting place, and that would be a displacement. So pause this video and do this check-in. The correct answers should be that B runs a farther distance, but A has a bigger displacement. When it comes to displacement versus time graphs, these are going to be super useful for telling us something, so we'll be creating them quite often. And so in all of these pictures, you can tell that the object is moving an equal amount of space every second, and that will create a very linear graph, and you're going to have what is called constant motion. And so constant motion is going to be represented always with a straight line. Now, if you have a curving line, that means that the motion is changing in some way. So for example, all of these objects show something either speeding up or slowing down. And so if something is curving upwards, you're having an increasing speed. And if you're having something curving downwards, you're having a decreasing speed. So before we go on, double check that you can draw one of these graphs using this motion. Be careful, they're going to try and trick you with this word straight line. And so if you want me to talk about that one, I can talk about it. But in general, displacement versus time graphs have a gradient to them, or if you don't know what a gradient is just an increase or a decrease in the magnitude of a property. The only way you can see that on a graph is with a slope. And so we're going to be talking about slopes. And you can either do the gradient by doing an overall like this, doing the full kind of line, or you can make tangent lines and do the slope of your tangent line to represent what's going on. And so the gradient of a displacement versus time graph is going to be velocity, represented by a change in displacement over a change in time. And so you can calculate that by doing slope. Now, velocity, people often call it speed with direction. And so we have to be very specific in physics. Speed is the rate of change in distance over time, whereas velocity is the rate of change of displacement over time. And so it does have a direction associated with it. So in terms of the words to kind of talk about that, something with a direction is called a vector, and so you can either represent that by putting an arrow over the top to remind yourself it has a direction, or sometimes textbooks will bold things that are vectors. Speed does not have a direction with it. It's what we call a scalar value. It just has a size. Now, you can calculate average speed, which factors in the whole trip, your total displacement over your total time. Or you could do your instant speed, or instant velocity, by taking a tangent line and finding the slope of your tangent line. This is what your speedometer in your car does. Do a check-in, see if you can answer this question, pause. The correct answer should have been that you needed to go 15 kilometers hours to the -1. And so you can also graph a velocity versus time graph. And these ones are going to show how your speed changes over time. So I've got the pictures of those changing motions. And you can use the steepness to kind of tell you how fast something is changing. And the change is actually change in velocity over time, our acceleration. So that's our gradient is going to be acceleration. And the cool thing about velocity versus time graphs is you can also take the area underneath the curve by doing this formula down here and figure out how far away you've moved, your distance that you've gone. So distance is going to be equal to the final velocity v plus the initial velocity u divided by 2, aka average velocity, from top to the bottom, multiplied by time. Do a check-in, see if you can create a position versus time graph from this. And last but not least, acceleration is defined to be the rate of change of velocity. So it is that equation I showed you. It is the slope of velocity. So you take the final velocity minus your initial velocity over time. There are 3 ways to make an acceleration. You can either increase your velocity, kind of like stepping on the gas in a car. That's a positive acceleration. You can decrease your velocity in terms of magnitude. This is a negative acceleration, and I like to think of it as stepping on the brakes in a car. It is called deceleration in English very often. And there is actually a third way to do an acceleration because velocity is not only magnitude but direction. If you change direction, you will also change velocity. So back to our car analogy, it's like someone cranks the wheel to the side. You'll feel it in your body just like you would a speeding up or speeding down. IB physics will always have a constant acceleration. You cannot actually handle the mathematics behind a change in acceleration unless you take IB mathematics and you know calculus. And if you're curious, the gradient of an acceleration is something we talk about in English. It's a jerk. Hopefully this helps. I'll continue the rest of 2.1 in another video, but this is the start and it should help you with your practice problems.